All right, back right here. So these are the overall of recrystallization. You get your mixture dissolved into the solution, right? By make it hot, make it hot. Don't use too much amount of solvent. And once everything gets into the solution, you crystallize it selectively, make just your compound crash out, become a crystal. And then you do vacuum filtration just to isolate your compound from the solution. Some of you, when you do recrystallization, may require hot filtration at the very beginning, the dissolving part right here. Okay, only because this could happen. Right, when you try to dissolve your mixture in the minimum amount of hot solvent, well, even you heat it up at the boiling point, add more solvent, keep adding more solvent, still, man, not dissolve. I'll take a look right here. This is clear, right? This is completely dissolved. In the middle one, hard to tell, but if you put it side by side like this, we call positive control. Like this is just water. We can see that this is not completely dissolved. Okay, and this happens when you have something that doesn't dissolve in organic solvent. Could be sand, could be dust from the air. You have to get rid of those first. Okay, to do that, well, you cannot do a normal gravity filtration. You cannot. This is what happens if you, let's say, you try to dissolve your compound at like 100 degrees. Let's say water is your recrystallizing solvent. Okay, 100 degrees is boiling point now. Right, let's say sand or dust, which is not dissolved, not soluble in water, is still there. So your solution is not gonna be clear, right? So to do that, must sound easy. Just pour into do gravity filter. Okay, so just get all those dust or sand out. Well, this what happened. This is hot solution. This is cold solution. When you pour through the filter paper like that, you might see some crystal or solid or precipitate stuck on the filter paper, right? Because the temperature changed suddenly. Okay, when it changed suddenly, what you compound as you pour it, some of your compounds or impurity they crash out right away. So you're gonna have something like get on the filter paper, and that you lose yield. All right. To combat this problem, we call this technique hot filtration. It's a hot gravity filtration, right? Like you do yoga and you do hot yoga. Similar to that. Now, here's how we do it. So you're gonna set up, like, go back right here. This is a regular filtration, not gravity filtration, right? Same setup. You put this guy in a hot plate, okay? And this in the Erlenmeyer flask will contain some small amount of recrystallizing solvent, just a little, all right? And when it's hot, let's say at boiling point, let's say this is water, just heat up to 100 degrees, and then you're gonna take a pipette, take some of that hot solvent, and then you drip it onto the filter paper. Keep the whole system hot. Keep the whole system hot. To do if everything is hot and you pour the solution at 100 degrees, go to about 80, 90 degrees, well, your compound won't crash out as you pour, okay? Because nothing here is cold anymore. The whole system is hot. Keep everything hot. Everything will just go through. All right. So some of you may need to do hot filtration. Okay, and when you do hot filtration, the rest of the step, dissolving, recrystallizing, gonna be really smooth. All right. Okay, all right, let's move on to the next video. So let's say you have the crystal. How do you know, or what you have to do with it? Okay, so you're gonna do this in the lab.